So section 8.1, we're going to start talking just some really basic geometry. I don't know if you had geometry in high school, if that was anything that you came along with. I know sometimes students don't have a great experience. You don't like proofs. We're not going to do anything involving proofs. We're just going to get to know some basic stuff that you might encounter along the way. So the discipline of geometry, which is the topic of all of chapter 8. The discipline of geometry was formed out of the need to measure for construction. In fact, historians believe that geometry began with the Egyptians or the Babylonians, some of those cultures that built big pyramids and temples and things like that. They needed to be able to construct angles, because if you're ever able to travel and you see how amazing the construction is with the tools that they would have had, they just had to be great mathematicians to be able to do those things. Yeah.
I was watching a video about that. Like previous stuff, and it shows like the way like it's built on every jar. Like if you have like centimeters off, like the whole thing is falling out.
Yeah, the way the weight and the fact that they're still standing thousands of years later, right? Like our buildings that we build, you know, that our houses are going to fall down in 100 years, but the pyramids are still. And some of the stuff in like if you ever are able to go to Italy and you travel around Rome and things like that, just the buildings that they were able to build, it's just pretty incredible. And it's a testimony to like the geometry that they were able to come up with and to measure and get precision, like you said. Also, another place where geometry was very applicable was navigation. If you're traveling the seas on a sailboat, then you needed to be able to calculate angles to the stars, because that's how they navigated back then. They didn't have GPS, unfortunately. And so then navigation turned into curiosity and studying astronomy and the movements of the stars in the sky and the planets and the moon, and being able to predict with great precision, you know, when an eclipse was going to happen, or the different phases of the moon, to be able to tell the season. So for some of this, it was survival, right? It's what became curiosity was survival. You needed to know when to plant your crops, when to do things, and that's, you know, that was how astronomy was useful. Okay, so the way that geometry developed, it starts off with some basic terms. So it got formalized, okay, it got used, and so then mathematicians along over the centuries formalized it. So the most basic object in geometry is called a point. Unfortunately, is one of those things that is kind of an undefined thing. You just kind of know what a point is because it's there. While you can't formally define it, a point is conceived as a location in space, and it has no length or width or height. Okay, so it's just again, I'll say it's just a point. It's hard to define. So when you're using your GPS in your car, and you know, if you look at the latitude and longitude, it becomes a point. They intersect at a point that has no dimension except where those two things intersect. So from points, then we build up other things. A line is just a set of points. And again, we intuitively know what a line is. You can take a ruler and use your pencil and you can draw a line. And so any two distinct points determine a unique line. Okay, so if you have one point, if you make a dot on your paper and then somewhere else on your paper you make another dot, you've just defined a unique line. Okay, and then if you defined another dot somewhere else, you'd make another unique line. Okay, so going on, again, I'm just telling you the basic terminology right here. A line segment is the part of the line between 2 points, and that includes the endpoints. Okay, so if you draw just a little line that starts and stops, that's called a segment. Okay, a line, what we just defined previously, a line goes on forever in the two directions that you would connect the dots with. When we draw lines, I don't know if you remember your algebra, but when you draw lines, the way we denote that lines don't have a stopping point is we use arrows on the end. So we would draw something like that to denote that a line that this is a line. And I'm going to teach you, or I'm going to show you the different notations in a minute. For a line segment, you wouldn't put the arrows. You would just put the starting and stopping. Some books, some teachers will put dots there like a barbell, just to let you know that it has a starting and stopping point. So just different notations. And so then the last one, the last basic term that I'm going to define for you here is what's called a ray. A ray, like a ray of sunshine, is half of a line that includes the endpoint. So a ray basically starts at a point and it goes in one direction. So you put an arrow on it because it never stops. Okay, so line segment, ray, those are kind of the basic objects that we're going to use. So again, math people, they love symbols. They like to write as little as possible because math people are fundamentally lazy. Okay, so a point, if you want to denote that you have a point, that A is a point, what you do is just put a little dot in front of A. So that when you're reading something, if you come across that notation, that means that you have point A. If you want to indicate line AB, then what you would do is you would write A and B, because remember, you need 2 points to determine a line. And then above that, you'd put the line with 2 arrows. The arrows are important. Okay, so notation becomes somewhat important here, so make sure you look at that detail. If you don't put the arrows, you're going to be communicating something else. In fact, let me go over to the right. If line segment AB, if I just do the A and the B and I just put the line over it with no arrows, that's a segment. That's a starting and a stopping point. Okay, that's the difference. Sometimes on the test, I'm pretty sure students know what they're trying to tell me, but they've just told me in the wrong way. So make sure you see that one little detail right there. Rays, so a ray is important, the order. If I tell you ray AB like this, if I tell you the A and the B and I put the arrow over it like this, what that communicates, okay, again, details are important. What that communicates is the ray starts at A, and then it goes in the direction of B forever. Because rays only go in one direction forever. They have a starting point, and then they go forever in one direction, like a ray that comes out of the sun. So if I do it the opposite way, if I do BA and I put the arrow over it, that's the ray that starts at B now and goes in the direction of A. Those are 2 different things. Okay, so these are different. And the last couple bits of notation, and then we'll do some problems here. An open segment means that I'm not including the endpoints. So let me write over here in parentheses, we don't include the endpoints. And so what you do is above the AB, you write a line, but then on the ends, you put like two little open circles, 2 little bubbles. So that, again, communicates that you have a line segment, but you're not including the endpoints. And so that's called an open segment. Then last but not least, a half open segment just means that you're not including one of the endpoints. So either A, B, or just depends on the problem. Okay, so notice only one of the sides of the segment because it's half open. Only one of the sides, one of the endpoints has the bubble because you're not including one of them. The other's included. So on the first one, A is not included, B is. On the second one, A is included, B is not. Okay, so that's the notation that you're going to encounter as you go through your homework and you go through these sections in this chapter. So let's apply it a little bit. So I'm going to do some problems here down at the bottom of the page, and then we'll flip the page and you'll have some similar problems. Okay, so example 1. We're going to use this line right here, AD, to determine the set that's represented by each of these 3 problems. So the first one says I've got segment AB. So I've got the segment that starts at A and goes to B. So I'm just going to just draw it like that. That's segment AB. Remind me, this is a blast from the past. What does this symbol mean? Union. What does the union tell me to do? Everything. Yeah, we're going to glue it together. Okay, so this is just remembering that this means the union. The union means include everything. Okay, you're just gluing everything together that you see. So what we're going to do is we're going to union AB, and we're going to union that with AD. So I'm right below it. Okay, I'm just going to do another segment. I'm going to start at A and all the way over to D right here. So when I smush those two things together, okay, when I include everything that's on one of those pink lines, where does it start? Starts at A. Where does it end? Ends at D. The endpoints are included, so it's just a segment. All right, well, let's do B. Maybe B will be a little more interesting of a problem. So I've got segment AB again. So let me just cover over this in purple. We'll use different color here. So AB. Now we're doing this. What does this mean? Anybody remember what this symbol means? Okay, this means the intersection. And what does the intersection, what does that communicate to you? Yeah, what they have in common. Great. So AB, I want to intersect it with AD. So here is my AD. Whee! So now they're kind of pink and purple. So now this time I'm not smushing them together and taking everything. I'm just taking what they have in common. So looking at those two segments, what do they start having in common? Where do they start? Yeah, right here. You can see they have them both right here at A. And where do they stop having both things in common? Okay, great. So these two problems are just kind of simple. Remember, simple doesn't mean easy, but they're simple examples just so that you get the gist of what's happening. So I'm going to do one more. If you got any questions at all, please feel free to ask. I love questions. It means that you are tagging along with me and processing stuff. Okay, so this last one, we're going to take BC. So I'm going to use a different color here, and I'm going to go above this line. So BC, so B to C. We're going to union it. And this time we're going to union it with C to D, but notice there's a little arrow above it. So it's the ray that starts at C and goes in the direction of D. So I'm just gonna write it like that. So segment BC goes from B to C, starts and stops. Ray CD starts at C and goes in the direction of D. We are unioning this. Union means take everything, we're smushing it together. So when I smush these two things together, where does it start? At B, and what does it do after that? It goes, what's that? It goes to D, and then since it's a ray, it keeps going. Okay, so you have a couple options here. Here's the thing that you have no choice over. You've got to say the starting point is B. Okay, that part is mandatory. But a ray, you just pick the other point to tell the direction. So you have a choice of one of two things. Either of these things are right. You can either say this is the ray that starts at B and goes in the direction of C. Or you can say it's the ray that starts at B and goes in the direction of D, the other point that's that way. It doesn't matter. Those both mean the same exact thing. So on the test, I would accept either if that was a problem that I gave you. So don't worry. You don't have to freak out. I would know that those mean the same thing. All right, so on the next page, I've got three very similar problems for you just so that you can take a couple minutes and sort through these on your own. So try those ones, see how it works. All right, so I'm going to start with the first one, and then if you need more time to do the others, just want to make sure that we're seeing what's going on. So the first one says I've got the ray that starts at B and goes in the direction of C. So here's my first ray. I'm just going to draw a nice little ray right there, and I'm intersecting with the ray that starts at D and goes in the direction of B. So just right under it, here's the ray that starts at D and goes in the direction of B. So that ray right there. So again, we're intersecting. So we want to know what these two things have in common. So where do they start having things in common? So right here, this part right here where my pen is, do both of those things have anything in common right here? Yeah, starting at B, right? That's where both rays exist. Does everyone see that? I know this can be tricky, so I want to make sure we feel pretty good about it. So this starts at B, and then where does it end? Where do they end having things in common? At D. So out here, there's nothing in common. Out here, there's nothing in common. So what is that figure? It has a starting point. It has a stopping point. So it is a... Okay, lines go forever in both directions. A ray goes forever in one direction. But what one starts at a point and stops at a point, that is the segment. So I'm just going to I'll put in parentheses that this is a line segment. I put the notation right above it, just the line without any arrows over it. Yes, sir. That's a great question. So because it's a ray and I know it goes forever, I just get in the habit of writing it out all the way. That way I can always see what they have in common, or what the union would be. So just extend it as far as the drawing will let you as a little bit of a help. But either way, even if you just did it from B to C, make sure you put that arrow, because that arrow communicates to you that it keeps going. Don't for ray BC, don't put a dot here. It doesn't stop at C. C just tells you the direction that that ray is going in. So the next one is I've got ray BD. So I'm just gonna do this down here. So note for next semester, I think I just need to repeat the drawing to be a little helpful. So B to D goes in this direction right here. So starting at B and going in the direction of D. And then I'm unioning it with the ray that starts at D and goes in the direction of B. So goes forever in this direction. So again, both of those are rays. They're both going forever in both directions. This time I am unioning. Unioning means take everything. So what happens on this end of the union? Does it have a starting place? No, it keeps going, right? Would you agree with that? And what happens as I go further to the right? Does it ever stop? No. So what kind of figure goes in both directions and never stops? A line. Okay, this one's a line. Okay, so on the end here, I'm just going to write my answer over here. Now, again, you have choices for lines. A segment, you don't have a choice. You have to communicate the starting and the stopping point. But remember, any 2 points determine a line. So your answer could have been line AB, or maybe you wrote down BD, or maybe you wrote down AC. I'm not going to write all the options, but basically, as long as you included any 2 points on the line, you have to have 2 different ones, you're right, okay? And that you have your line symbol above it. All right, the last problem that I gave you to work out was segment AC. So here's the segment that starts at A and goes over to C right there. So from A to C is what I've tried to line it up. Hopefully that's fairly clear. We're going to union it with the segment that starts at B and goes over to D. So I got my dots for my starting and my stopping point. So here's the A to C. Here's the B to D. I'm unioning again, so I'm smushing all this together. So when I smush it together, what kind of figure is formed? I'm sorry, what'd you say? A to D, great. There's a starting and a stopping point. So what kind of figure has a starting point over here and a stopping point here? That's a what? Line segment. Perfect. You're going to encounter more problems as you go through my math lab of that same sort of thing. So it's just a matter of getting familiar. So keep your note sheet with you. Remember what a line segment is, an array, and what makes them different as you go through those problems. So continuing on, we've talked about line segments. Now that's not too interesting. You basically have one way you can move on a line segment. You can either move left or right, which is kind of the same thing. So now what we're going to do is we're going to increase our degrees of freedom here, and we're going to talk about what's called a plane. So a plane is a two-dimensional figure. So now you're going to have two ways you can go. So if we're on the floor, we can either go front or back is one way you can go, or left or right is the other way we can go. So we have two what's called degrees of freedom. So plane is a two-dimensional surface. I just thought it's kind of ironic that we call planes that go in the sky. They can go in 3 dimensions, but we call this two-dimensional thing. Anyway, sorry, that's just bad math brain. Okay, a plane is a two-dimensional surface that extends infinitely in both directions. So what that means, like if you're looking at the whiteboard is what a plane would look like, but then as long as it goes forever, up and down and left and right. So a plane extends infinitely in all directions. Any 3 distinct points that are not on the same line determine a unique plane. So I don't know if you've ever wondered this. Why, if you like to take pictures, and you'll notice that when I do my camera in the class that I put on the desk there, I use a tripod. So I don't know if you've ever wondered why tripods have 3 legs instead of 4 or 8 or however many legs. Well, the reason is because since a tripod has 3 legs, anywhere you set it, it's going to be stable, because 3 points, the 3 ends of the tripod, determine a plane. And so anywhere you put it, so if you're on some rough ground, as long as you can extend the legs and get it stable, you have now determined a plane. If you've ever been to a restaurant, like anytime I go to Panera, I sit at a table outside and it rocks. If you've ever been on a table that rocks, what it means is one of the legs is shorter than the others, so that table is rocking between 2 planes. Okay, 3 of the legs are stable on one plane, and then it rocks, and the other 3 legs are stable. So 3 points, the reason for that is because 3 points determine a unique plane. 2 lines that are in the same plane and do not intersect. Does anyone know the word for 2 lines that don't intersect? Okay, that's fine. Somebody else might have said it, but I couldn't quite hear it. There you go. Parallel. Parallel lines are 2 lines in the same plane that don't intersect. And so a 2-dimensional figure that we're going to talk a little bit about, and that's kind of where section 8.1 and 8.2 will kind of be about our 2-dimensional figures. So an angle is a 2-dimensional figure that's created from the union of 2 rays with a common endpoint. So an angle is 2 rays that originate at the same place. And in fact, what I also should have told you here, so that common endpoint, that's called the vertex of the angle. The symbol for the angle, you use this symbol right here. It's an angle. Okay, angle ABC is how you would write that angle. The order when you write your angle is important. The letter in the middle is always the vertex. So what I'm communicating to you when I say angle ABC, I'm telling you B is the vertex. So the other 2 letters don't matter. Angle CBA would be the same thing, but B has to be in the middle. So now that we have 2 dimensions, we're going to do some other problems. I'm going to do the first one, and then I'll give you some time to do the other one. So I've got this figure over here on the right. Okay, I've got 3 lines that are all going in different directions. I've labeled points on all those lines so that we can talk about all those different angles that are there. So the first one says I have angle FCD. Okay, so as I just said, I'm going to mention it again. What is in the middle, that's always the vertex. So FCD is this angle right here. C is going to be the vertex. So it's going to be this angle right here. I've got F, I've got C, I've got D. So you've got two rays. Angles go infinitely in both directions, and they meet, the two rays meet at the vertex, that point C. So I'm intersecting those. So I've got, oh, sorry, I've got angle FCD. I haven't done the other angle yet, so I got a little ahead of myself. So then the other one is HCD. So here's HCD. So let me, in pink, if you can tell, we'll draw this one in pink. So my purple angle is FCD, my pink angle is HCD. In both cases, C is in the middle. We are intersecting. So what do those two angles have in common? Okay, they have the vertex C. That's great. And then what happens along here? I heard somebody say D. Does it stop at D, or do both these sides keep going? They keep going. So what we have, what is a figure that starts at a point and keeps going in a direction? That's a ray. So that is ray CD is what they have in common. These exercises are just designed, or the purpose of them is just to allow you to get familiar with these figures. So same thing for you in the B problem. You've got two rays that you're unioning. So see if you can figure out what they make. Okay, this problem has ray Fi, so it's the ray that starts at F and goes in the direction of I, so I've put it in black right there. And then ray Fg, so it's the ray that starts at F and goes in the direction of G. I am unioning, so what figure is created when I glue those two rays together? Got an angle, that is great. And so then IFG, yes, or GFI. Either way, but the F has to be in the middle. If you put FIG or GIF, if you put the F somewhere that's not in the middle, that is wrong. Okay, that's a different angle. All right, give the next one a try. Maybe you have already, but I'll give you another 30 seconds to map that one out. So this one, I've taken ray AC, so the ray that starts over here at A and goes in the direction of C. So there we are in nice orange. And then ray EF, the ray that starts at E and goes in the direction of F. And what happens with those two things? I probably should have traced right on the blue, but what happens with those two things? Where do they intersect? Yeah, they intersect at this point right here, B. So I'm going to write the answer as point B, just like that. Last one, we're looking at the intersection of those two angles. right? So angle ABE, so that's this angle right here. So I'm just gonna try to darken this up right here in vibrant blue. So there's ABE, and then angle FBC. So that's this angle right here. And so where do those two angles intersect? Again, at point B, they share that vertex and nothing else. So that problem is done. Any questions so far? Just getting familiar with these figures. All right, so let's talk. I'm sorry? What'd you say? Not yet. We're getting close though. All right, so we're starting to talk about angles. So angles get classified according to how what their size is. So there are basically 4 types of angles. The first type is what's called an acute angle. And an acute angle has an angle measure, I'm just going to call it X, that is between 0 and 90. So for instance, on the sheet, just so that I don't make a big mess of this, if you look down at example 2, the angle CBA right there, that is an acute angle. Okay, it's less than 90 degrees. Okay, the next kind of angle that you're going to encounter is called a right angle. No, CBA, point C right here to B to A. If you're looking at the one by example 3 right here, if that's where you're looking, DBA, you're exactly right. That would be an acute angle too. The next one's called a right angle. Right angles have a measure of 90 degrees. Okay, 90-degree angle like the wall and the floor hopefully have. So in the one that's to the right of example 2, DBA, and that one is a right angle. Sometimes when you're looking at pictures, you might see in the book, or somebody might draw, they might put like a little block there. That'll tell you that's the symbol that you have a right angle when you have that a little block like that in there. On that example, they didn't put it just because it makes a little bit of a mess, but that's okay. I love messes. The next one is obtuse. An obtuse angle has a measure that's bigger than 90 and less than 180. 180 would be just straight across. So in the drawing that's to the left of exercise 3, this angle right here, the ABC angle, that is obtuse. It's bigger than 90 degrees. And then lastly, I don't refer to this one too much because it's the same thing as a line, but it's technically an angle as well. A straight angle is an angle that is 180 degrees. Okay, we're just going to do a couple more things, and then we will call it a day. So I've got 2 more things. We're going to fill in the blanks. We're going to do the next 2 exercises, and then we'll stop and we can finish this one up when we come back on Tuesday. So 2 angles, they are called complementary. Two angles are called complementary angles if their sum adds up, the sum of their measures adds up to 90 degrees. And then the last word for the day, 2 angles are called supplementary. If their angles add up to 180 degrees. So I'm going to do example 2, and then you're going to do example 3. So here's how this looks. Example 2, we're using this figure over here on the right. Okay, so for example 2, I'm telling you in the figure that angle DBC So DBC, I'm just going to make a little arc here so that we know what we're talking about. Angle DBC and then angle ABC. I'm going to make another arc right here just so that we know what we're talking about. That those two angles that I've done those little orange arcs in, those are complementary. Complementary means they add up to 90 degrees. I then tell you that the measure, this little M right here, when you see it, means measure. The measure of angle ABC is 34 degrees. So this one right here is 34 degrees. We need to find the measure of DBC. Okay, so I'm just going to set this up. The reason I'm going to set this up is when we come back on Tuesday, we're going to do a problem that's slightly more complicated. So it'll be handy if we see this. So I don't know what this one is. I want to know what DBC is. So I'm just going to put a little question mark there in that angle. And so here's what I've got. I know these two angles are complementary. So the question mark, the angle I don't know, plus the 34-degree angle, since they're complementary, they add up to 90 degrees. So, I mean, you can use your calculator. You can do a quick little algebra. What am I going to do? What am I going to do with the 34 and the 90 in order to figure out the missing angle? I'm going to subtract them. So you just pop that into your calculator, and 90 degrees minus 34 degrees is going to be, I think, 56 degrees if I've done my arithmetic properly. All right, so you have one final problem. I'm going to give you 60 seconds to do exercise 3. We're looking at the angles on the left. I've told you that they're supplementary, and you need to figure out the missing one. All right, so in this problem, I tell you that angle DBA, so this one right here, and ABC, so this big obtuse angle right here, I've told you those are supplementary angles. They add up to 180 degrees. I've then told you that ABC is 115 degrees, so we need to figure out what is this missing angle over here. So I'm just going to set it up again. I know that you could do this one probably without setting it up. I'm doing this so that when we come back next time and we do exercise 4, we'll see exactly how the setup works there. So this means that the angle I don't know plus the 115-degree angle is equal to 180 because they're supplementary. And so again, what do I do with these two numbers in order to figure out what's missing? Subtract them, and when you subtract them, you end up with 65 degrees. All right,